Assalamu alaikum, everyone. Can everyone hear me? Hello? Okay, अच्छा. तो let's get started. अच्छा, तो Slack के ऊपर हमने वो पहले से ही मैसेज कर दिया था कि the agenda for today's tutorial is कि we're going to be doing an example on KD trees. Then we're going to be reviewing all of these topics in evaluation metrics. Now, up tak, the only thing you've gone through so far na, is evaluation based off of a single class classifier model, right? So in the next week, you're going to be going through how to extend this thing to multiple classes, to multinomial classifiers. So without further ado, let's just get started. Acha. So starting off with KD trees. Now we're just going to be doing the example in the lectures because Dr. Aga has asked me to elaborate on that just a bit more, right? So as you guys should recall, the steps to constructing a KD tree is suppose that you have some data that I'm going to write out like this. So you have 1,9, 2,3, 4,1, 3,7, 5,4, 6, 8, 7, 2, 8, 8, 7, 9, and 9, 6. Now, usually when we start writing out things like this, now you'll notice that every one of these tuples, these represent individual data instances. So यहाँ पे I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to have 10 of these data instances, and each of these have 2 dimensions. So what the KD trees algorithm says, okay, we're going to start off with picking a random dimension. And then we're going to split the data set based off of finding the median of these values within that dimension. Use that to make the split. And then we're going to repeat. So these 3 steps, they're really easy. So we're going to be doing this for 2 dimensions only. So pehle iske andar na you see ke acha picking a random dimension. That basically means that if we have 2 dimensions over here, right? So 1 and 2, you can just start off with picking the first one. So us lihaz se I'm going to denote this thing as x superscript 1. So iska matlab hai ki we're going to start off by writing down each of these values. So it's going to be 1, 2, 4, 3, 1, 2, 4, 3, 5, 6, 7, 8, 7, and 9. And now what's going to happen is that the KD trees algorithm, the reason why we decide to find the median of all things instead of the mean is because we want to split these things into 2 halves exactly. Now, if you would find the mean, right, it would be susceptible to maybe outliers. Jiski wajah se you might not get a perfectly even split. But जो median होता है, that says कि I'm going to find exactly the midway point जिसके ऊपर ना मैं पूरा partition करूंगा. तो यहाँ पे you see कि if there's 10 samples, right, I'm going to make the split like this. So it's 1, 2, 3, 4, 1, 2, 3, 4. Now these 2 things, यहाँ पे I'm going to find the median. That's going to be 5.5 actually. So if I were to start constructing this tree, I'm going to use this thing as my root node. So I'm going to create my partition starting off like this. So they're going to be x1 is greater than or equals to 5.5. Again, so if I'm partitioning based off of splitting the data into 2 halves, that means I'm just going to have a binary condition. So it's just going to be greater than equals to or lesser than, right? So that's going to be my root node. Now I'm going to say that the left branch, that's going to be for when a data point is not satisfying this condition, and the right one is going to be for when it does. So uske mutabik, I'm going to start partitioning this data set again. So here you'll see that if I start listing off of the second dimension values that satisfy this inequality, I'm going to get 8, 2, 8, 9, 6. And if you're wondering where this is coming from, so if I have x1 is greater than equals to 5.5, so I see that yahan se na it starts off. So yahan pe that's how I'm getting 8, 2, 8, 9, and 6, right? Similarly, yahan pe I'm going to get 9, 3, 1, 7, and 4, right? Now, if I were to find the median again, I would have to sort this. The reason I didn't sort it in the first place was because it was already kind of It wasn't a good enough state कि मैं directly कर सकता था. But यहाँ पे we're going to sort this again. So it's going to be 2, 6, 8, 8, 9. And then we're going to see catch a fine. These are two halves. This is going to be the median. So now we're going to create our second node. This ऊपर is going to be x2 is greater than or equals to 8. Similarly, यहाँ पे I'm going to have 1, 3, 4, 7, and 9. I'm going to take these two chunks, throw them away. This is going to be my median. And then I'm going to have this, right? So यहाँ पे I've partitioned the data on two levels. So if I were to draw this out roughly, and then you can imagine that this is basically x1, and then this is x2. So my root node is going to basically split kind of like this. So basically, if this whole thing was the original feature space, I've now partitioned it into two halves, 1 and 2. Then the other ones, they're going to say basically, okay, if x2 is greater than or equals to 8, that means I'm creating a split kind of over here. And if x2 is greater than or equals to 4, then I'm creating another split kind of over here. So यहाँ पे you can see that for every single node that we have, now we're partitioning the space into two more halves, right? So if I were to go into this branch, right, that means I'm purely looking into this section of the feature space here. Let's get rid of this. अब क्या होगा इसके suppose we decide to stop our algorithm over here. Now there's not necessarily a stopping criteria for KD trees. So suppose we decide to stop it with this tree of height is equals to 1. अब क्या होता है इसके if you want to make a prediction on some query instance that's coming in our system, then we're going to have to actually find out okay, fine, within this specific node over here, right, what is going to be the most common label. Now उसके मुताबिक we'll actually have to list out कि fine, यहाँ पे ना हमारे कौन से instances आ रहे हैं. So again, suppose this branch is for when the condition is satisfied and for when this one isn't. So we're going to find fine 6, 8, 6, 8, 8, 8, 7, 9. And then for when this condition is false, it's going to be 7, 2, 9, 6. 1, 9, 3, 7, and 5, 4, 2, 3, and 4, 1. Now the thing is that initially यहाँ पे, these were the inputs, right? These were the inputs or the features, right? So these were the X's. यहाँ पे ना, we haven't necessarily written down what the actual labels are for each and every one of these instances, but you could say कि अच्छा fine. Suppose this instance was it had a class of A, this one also had a class of A, this one had a class of B. So if I had, for example, some query point, जैसे suppose I said xq is going to be 7, 9, and we had to make a prediction off of it, right? So what's going to happen is I'm going to say अच्छा fine, this 7. Now x superscript 1 says greater than or equals to 5.5 now. So I'm going to go in this direction. Then I'm going to see fine. X superscript 2 greater than or equals to 8. This is also being satisfied. So I'm going to go over here. Now that I'm in this pool, right, I'm just going to see fine. यहाँ पे majority label क्या है? So I'm going to say fine. I have 2 A's and 1 B. This implies that I'm going to predict class A. It's that simple, right? यहाँ पे सिर्फ ये होता है, it's going to predict the majority label of the section it falls into, right? Anyone have any questions regarding this? Okay. Now we can move on to the next section, something that's less boring. अच्छा, तो okay, now precision and recall. Can someone in the meeting remind me what precision is equals to in terms of true positive, false positives, false negatives, and true negatives? Just unmute and speak. Okay. Acha. So precision, as you might recall from class, is going to be the portion of true positives in the space that I have in the space that my model is going to predict a positive value. So that basically means that it's going to be this ratio. And recall is going to be essentially the same thing, except that it's going to have false negatives over here. Now you might notice that, acha, fine, I have false positives over here and I have false negatives over here. This is going to actually help me figure out, acha, fine, if I have a classifier that has the possibility of making like, two types of errors. So if you might recall, now there's this thing that we call a type 1 and we have a type 2. Type 1 are false positives and type 2 are false negatives. Now what's going to happen is that you're going to learn this बाद में something that we call the precision recall trade-off. But essentially ये होता है is कि your model can't minimize both things jointly. So it has to decide whether it's more important to minimize false positives or to minimize false negatives. Now, you're going to have precision and recall to decide fine, which one of these errors should be minimized by this model. Now, a really easy way to remember this is if you remember the formulas, is you can just see that fine, यहाँ के denominator के अंदर ना I have false positives. So if I have more false positives, right, that's going to imply that my precision is actually going to fall. So this implies that precision seeks to maximize, but actually seeks to minimize my false positives. And then similarly, following this logic, okay, false negatives agar बढ़ जाते हैं, then my recall is going to fall. This implies that my recall seeks to minimize my false negatives. Right? Now, here is an example question. Right? So, is it possible to have perfect precision but zero recall? Or vice versa? Does anyone want to give this a try? Over here. Raise your hand. Seriously, no one? Okay. Okay, so if you go just off of the formulas over here, na, so precision ke andar you can see that this is going to be TP over TP plus FP. And recall ke andar you can also see that TP is equal to TP plus FN. Now, ab kya hoga ki if you have a perfect precision, right? If you have a perfect precision, and perfect precision ka matlab hai ki P is equals to 1. This would imply that your true positives are actually greater than or equals to 0. Now, if your true positives are greater than or equals to 0, then that implies that your recall can never be equals to 0, right? So the answer to this question is no, this is not possible. It isn't possible, right? Let's do another question. Okay. Now, suppose we are given two confusion matrices. Now, I'm going to write it down like this. No. So I'm going to have y is equals to 1 over here, y is equals to 0 over here. And I'm going to have two classifiers, right? So I'm going to have model A, and this row is going to be for when it is going to predict something that's positive, right? And this row is for when it's going to predict something as being negative. I'm going to have a second classifier, and the same thing over here. I'm going to list out the following values. 202, 100, 4, and 190. Right? Now, I'm given the task of finding the precision, the recall, and the F1 score that we'll revise in a bit for each of these classifiers, for each of A and B. Right? Now, you guys can practice this on your own time, but for brevity, I'll just start doing it right now. Okay, so starting off with precision for model A. Now you're going to remember that this is going to be TP over TP plus FP, right? This is going to be, we also call this the true positive rate. So in a quiz, if you ever come across the word true positive or specificity or something like that, so then just remember that these are still derived from the TP, FP, FN, and TN, right? So precision of A. So यहाँ पे we can see कि true positive का मतलब है कि at what point did the model predict something that was positive and when it was actually right. So that means I'm going to be looking at this value first, right? So for model A, my TP is going to be 202. And because I also have another TP over here, I'm also going to write down 202. Now, false positive का मतलब है कि when it predicts one again, but it was wrong in predicting one. So then I'm going to be looking at this value of 100, right? अब ये होगा कि that is actually going to be 0.6689, right? Now, similarly, I'm going to do this for the recall. Recall of A, that's going to be TP over TP plus FN. 202 over 202 plus, and again, so false negative का मतलब है कि it predicted something that was negative, but it was wrong. So I'm going to be looking at this value over here, right? So 104. And that is going to give me a value of 0.6601, right? Now, jo ye F1 score hai, I'm going to come back to that in a bit, the F1 of A. Let's do the precision and recall for model B. Acha. So precision of B, again, that's going to be precision of B, that's going to be for when it was right and predicting the positive class is going to be 100 and 199. And the false positives are going to be when it predicted one, but it was wrong in doing so. So it's going to be 97, right? There's going to be 199 over 199 plus 97. That is going to be 0.6723. Now the recall, that's going to be 199 over this thing again, over 114. So that's going to be false negatives, as in it predicted something that was negative, but it was wrong in doing so. It's going to be 199 over 199 plus 97, I believe, right? No, 114. Okay, so that's going to be 0.6358. Anyone have any questions so far? We just found the precision and the recall for these two classifiers. Okay. So from class, you should hopefully remember that the F1 score is going to be the harmonic mean of the precision and the recall. Now, we're going to derive that baad mein, and we're going to revise what the different types of means are. But for now, just for the sake of recall, just remember that it's going to be 2PR over P plus R, I believe, right? So 2PR over P plus R. So if I'm calculating the F1 score of classifier A, I can just use these two values and just plug it into this formula. So that's going to be 2 times 0.6689 times 0.6601, 0.6689 plus 0.6601. And this, if I put it into a calculator, I'm going to get 0.6645. Right? Same thing over here. F1 of B is going to be 2PR over P plus R. It's going to be 2 times 6723.6358 over 3 plus 6358. And that is going to give me a final value of 0.6535, right? So this is having calculated all of the precision measures that you've learned so far for both of these classifiers. So iske andar you'll actually notice that for each and every one of these values, we've never actually considered what the true negatives are. Because there's another metric, I believe, that's called the specificity. This you actually find out this thing that's called the true negative rate. So that's kind of like, the opposite of the true positive rate that we also call the precision. So iske andar you'll notice that if you have this sort of matrix, right? इसके ऊपर ये चीजें हैं. So the things that are on the diagonals, na, that basically says कि when the predictions of your model are correct, and these two things, they're on the off diagonal, so to speak, or when the model's prediction is wrong. And those are the only two things that you're going to be fixing into, like, these small precision and recall formulations over here, right? Any questions? Okay. Acha. Now we're going to take a small tangent and talk about the types of means, right? So the thing was कि जो ये F1 score होता है, right? That is just a way of combining the precision and the recall into one thing. But अब क्या होता है इसके you want to actually figure out कि अच्छा what's the best way to actually combine these two metrics to create, like, this aggregated one. क्योंकि ये होता है कि you have actually three types of means. You have the arithmetic mean, you have the geometric, and you have the harmonic. Now the thing is कि the arithmetic mean is the thing that is going to be the easiest to calculate. That's the thing that everyone is familiar with. So just for the sake of completeness, we're going to actually write it down. So the arithmetic mean, I'm going to denote this as AM. This is going to be the sum of all values in an array. Suppose I have, like, I have x1, I have x2, x3, so on, right? So there's going to be the sum of these things divided by n. मगर इसके अंदर क्या होता है इसके the arithmetic mean is going to be very sensitive to outliers. Very sensitive to outliers. इसका मतलब ये होता है कि suppose कि I had precision and recall being equals to, like, let's say कि precision was 0 and recall was 1. Or suppose it was the opposite, because I believe you actually did this in class. So if you take the arithmetic mean of these things, now you take the arithmetic mean, then you'll actually get 0.5. Now this says that your model is kind of performing at, like, some medium level of performance, and that's actually a really bad representation of how the model is performing, because if it has zero recall, right, that means that it's performing extremely bad when you're trying to minimize the false negatives, if you can recall that. So इसके अंदर ये होता है कि you want to basically strive for something जिसके ऊपर it's going to penalize your model if it's bad on both sides. So for geometric, it's going to basically be the nth root of the product of n values. So that basically means that you're going to have something like this. You're going to have the nth root. You're going to have x1, x2, all the way up until xn. Now, if you look this up online, you'll actually find some resources that say that this is good for when data points have varying scales. Now, what do you mean by varying scales? Varying scales का मतलब ये होता है कि suppose कि you have, like, data that comes from a data set of cars, for example, right? So you have, like, let's say you have a feature vector that says, this is the number of doors, this is the number of wheels, and then this is the number of, actually suppose we have, this is the price of the thing in dollars, and then you finally have, like, the mileage, like let's say it actually went for like 150,000 kilometers, right, when you took this instance. अब क्या होता है कि if you find out the arithmetic mean, right, this is going to be really biased towards, like, it's going to tend towards this side actually. So it's actually going to start ignoring this 4 and this 50,000. Now the geometric mean, that basically says, okay, I'm going to take the fourth root of 4 times 4 times 50,000 times 150,000. And then if you actually calculate that, it's going to be 4 times 4 times 50,000 times 150,000. I'm going to take the fourth root of that, and I'm going to get 588.566. And then this is going to be very, very different from the arithmetic mean. So the arithmetic mean is actually going to be pretty close to, like, the high tens of thousands. It's going to probably be above like 100,000. So now finally we have the harmonic mean. And the harmonic mean is actually what we use for the F1 score. Why do we use this? Because this is specifically made for rates. Now, what do we mean by rates? Rates basically means any values that lie within this range of 0 to 1. So that's going to be perfect for when we're dealing with precision, recall, accuracy, like, those kinds of things. Now, another property of the harmonic mean is, we'll actually define this like this. Okay, it's going to be the number of values divided by the sum of the reciprocals. Now, if you were to write this out, that would actually be n over 1 over x1 plus 1 over x2 plus all over 1 over xn. That means that if we have n is equal to two values that I'm going to call the precision and the recall, I'm just going to have 2 over 1 over p plus 1 over r. And then you can do a bit of math and you actually find that this is going to be equals to 2pr over p plus r. And we're going to call this the F1 score specifically. तो इसके अंदर ये होता है, इसके suppose we're dealing with this expression specifically. Now, what's going to happen is if you have a very high precision, something that's like pretty close to 1, but you have a recall that's pretty close to 0. So what's going to happen is 1 over the recall, that is actually going to be a very high value. And if that's a very, very high value, then this harmonic mean, this whole thing, that's actually going to be really, really close to 0. So इसके अंदर ये होता है कि you can't have if you have n values, right, and one of them is really high, but all the others are low, so then that means that the whole array is going to be penalized. So it's basically going to be कि जैसे आपके पास resistors होते हैं that are connected in parallel, right? The harmonic mean of those things, that's actually going to be as strong as, so to speak, is going to be as strong as the weakest link in the chain. तो ये होता है कि if you want the harmonic mean, the F1 score, so to speak, of the precision and the recall to be high, precision and the precision and the recall, they should both be very, very high. So if you have precision and the recall both being 1 in this case, then you're going to have 2 over 1 plus 1. And that is going to be 1. Right? So again, if any value, and I'm talking about xi over here, so if it dips, then the harmonic mean falls. So everything in the arena, it has to be high enough for the overall harmonic mean to be also high. Any questions? Okay. Achha. Okay, now the F beta measure. Okay, so if you might recall from class, we defined the F beta measure to be 1 plus beta squared times the precision and the recall over beta squared P plus R. So यहाँ पे you can see that the P term over here, that's going to be weighted by this beta squared factor. तो अब क्या होगा इसके the F1 score is basically when F beta is going to be evaluated at beta is equals to 1. And that's just going to be 2PR over P plus R. Now we can look at the logical extremes for these things. So that specifically means looking at F0 and F infinity. Now जो F0 hoga, that's very, very easy to calculate. So F0, that's just going to be 1 times PR, that's just going to be PR. That's going to be 0 plus R. So that's going to be P. Now if you look at F infinity, right, that's basically going to be the limiting sum as beta tends to infinity, 1 plus beta squared PR over beta squared P plus R, right? So there's going to be a little involved math. This stuff is in the slides, but I was asked to cover this, so I will. अब इसके अंदर क्या होता है कि I'm going to basically factor out this beta squared term over here. अब इसका मतलब होता है कि I'm going to have 1 over beta squared plus 1 PR. I'm going to have this beta squared term also factored out over here. It's going to be P over beta squared. P over beta, no, sorry. If I factor this beta squared term over, this is going to be P plus, it's going to be r over beta squared, I believe, right? Yeah, that looks right. So then I'm going to see KHF fine. Even though these are like finite values, okay, when I take the larger and larger values of beta, I can cancel these out. Then I'm going to be left with this thing. Limiting beta tends to infinity. 1 over beta squared plus 1 PR P plus R over beta squared. So if I have a really high value for beta, I'm going to find KHF fine. R over beta squared is actually going to tend to 0. This thing over here, that's also going to tend to 0. So in the end, I'm going to be left with PR over P, and then that is just going to converge to the recall. So यहाँ पे you see catch a fine. We have F0 is going to be equals to P. Then we're going to have F infinity that's going to be equals to the recall. So यहाँ पे you have a really easy kind of formulation of this, right? Okay, if you have beta is going to be greater than 1, you're going to have more attention, so to speak, being given to the recall, more weight to the recall. And if you have beta being squeezed between 0 and 1, you're going to have more weight to the precision. And then precision and recall ke mutabik, then you can like find out कैसे define. If I have a system जहाँ पे my system could suffer if I have more false positives and false negatives, na, then I want to basically create a metric जिसके ऊपर I can tune this knob and come up with a measure of my own. Right? Now, एक आखिरी चीज थी कि the F0.5 and the F2 measures. These were things that Dr. Aga asked me to cover because these things are actually commonly used in the industry for when they want to have like, slightly higher weight to recall in the case of F2 and higher weight to precision in the case of F0.5. So you'll actually find F0.5, that is going to be 5 times PR. You can just plug this in and find it out yourself. P plus 4R. And then same thing over here, that's going to be 5 PR over 4P plus R. Right? So you can see yahan pe, right, that if I have a higher value for precision, that is actually going to increase my denominator, which is going to decrease the overall value of this F2. And that is going to follow in perfectly with this idea of recall, right? Okay, I want to give more weight to minimizing my false negatives. If I minimize my false negatives, there's going to be less room for me to minimize my false positives. So that means that there's basically this kind of trade-off between precision and recall that you guys are going to do more in the upcoming week. Any questions? Okay. Now we're going to do one question involving confusion matrices. Right? So confusion matrices ke andar, if you remember, we had the true labels or the ground truth, the gold labels on the columns axis. And then we had the predicted ones over here. So suppose I had plus over here, plus negative over here, plus over here, negative over here. So in matrix notation, I'm going to label these things as A11, A12. Basically, the first number is going to represent my row. Second number is going to represent my column. I have A21 and A22. Right? So a good exercise is to actually write out your precision, your recall, your accuracy, and your F1 score in terms of these specific values. So accuracy, as you would recall, that is basically going to be the portion of samples that you've predicted correctly on. So that's going to mean you're going to have in the numerator, there's going to be the sum of the elements on the main diagonal divided by the size of the total data set. So that's going to be A11 plus A12, A21, and A22. जो precision होगी, one good way to remember this is that's basically going to be this proportion of this divided by this, right? So that is just going to be A11 over A11 plus A12. And then your recall is going to be your your true positives divided by true positives plus your false negatives, A21. Right? Now, let's actually calculate, and this is going to be a good shorthand that would actually help you guys in the quiz. So for the people that are actually watching this one, you guys are at an advantage. So your F1 score hoga, again recall that it's 2PR over P plus R. So what I'm going to do now is I'm just going to substitute this in. Okay, I'm going to do this in parts though. So I'm going to have this P plus R term over here and this PR term over here. So जो PR term होगा ना, that's just going to be this thing times this thing. It's going to be A11 squared divided by A11 plus A12, A11 plus A21. Now, this P plus R term, that's going to be slightly trickier to evaluate. It's going to be A11 plus A12 plus A11 plus A11 plus A21, right? So अब यहाँ पे सिर्फ ये होगा कि I'm going to have A11 squared plus A11, sorry, A21, basically doing this cross multiplication over here, plus then this thing, A11 squared plus A11 A12. We're going to divide that by this product. और जो ये वाली term है in the numerator, that's just going to be me adding up this term and this term. It's going to be A11 squared plus A11 A21 plus A12, right? What I can do again is I can actually factor that out. So it's going to be A11 plus this term. Wait, did I do this right? There's going to be a 2 over here. So then that's going to be A11 plus A12, A11 plus A21, right? So that's basically me evaluating P plus R and PR. Now we're going to combine this to create the final F1 measure. So, right, that's going to be 2 times PR over P plus R. It's going to be 2, and I'm going to lift the value for PR. It's going to be A11 squared over A11 plus A12, A11 plus A21, divided by this P plus R wali cheese. It's going to be A11, 2A11, A21 plus A12. Now you see that I have this A11 term that's actually common in the denominator and the numerator, so I can just cancel it like this. And then you can also see that A11 plus A12 यहाँ पे भी है, यहाँ पे भी है. A11 plus A21. I can also cancel these things यहाँ से. So in the end, I'm going to be left with this thing. 2A11 divided by 2A11 plus A21 plus A12. Now, this is actually a shorthand that you can use for the F1 measure. Can someone unmute and tell me what A11, A21, and A12 stand for? We just went through this.
A11 is when your prediction is also like 1 and your true value, like the code label is also 1. Like, okay, it's the true positive basically.
Exactly.
A21 is when I think A12 is basically when you have like false positive.
So A12, that's going to be for when I predicted the positive, but I was wrong. So that's going to be a false positive. So this is going to be FP, and this is going to be FN.
Yes.
So basically, these things in the off-diagonal terms, no? Like, well, this was just for a simple recall exercise. But A21 plus A12, that's just going to be my false negatives plus my false positives. So, so F1 का एक shorthand होता है. It's going to be 2 times the true positives divided by 2TP plus FN plus FP. Right? Now let's do, actually, first of all, no, let's actually use this thing and go back to our original example over here. Right? So यहाँ पे हमने देखा था कि अच्छा, we have F1A is going to be this thing, and F1 beta, actually no, this should be F2, F1 of, actually sorry, this should be B. So that's going to be 0.6535. So up here, okay, let's actually use this thing, use the formula we just derived to see if we can get this faster. So if you had a question that just said, like, find the F1 score now, instead of going through this whole like, dance of going through the precision and the recall and then finding that thing using the harmonic mean. You can just find out the F1 score directly, just using this thing. So it's going to be, again, 2TP plus FP plus FN. So that means if I had the model A and model B, so I'm just going to plug this in over here. So F1, so for model A, what were my true positives? That was 202, right? So it's going to be 2 times 202 divided by 2 times 202 plus the off diagonal terms, right? So it's going to be 100 plus 104 plus 100 plus 104. Now there's someone over here with a calculator, and I just verify that this actually ends up being this same thing above, 0.6645. Similarly, for model B, I'm going to have 2 times 199 divided by 2 times this thing plus the off diagonal terms. 2 times 199, 2 times 199 plus, what were the off diagonal terms? 114 and 97. 114 and 97. Now, this should end up being 0.6645. And this thing should end up being 6535, right? So, bas ye hota hai ki, if you have a question in the quiz, for example, or in the exam that says, ki, find the precision and the recall and then find the F1 score, then it's going to be easier, ki, you don't use a shorthand because you've already calculated the precision and the recall. Versus, ki, if someone says, ki, just find the F1 score, then you can use this shorthand. And again, this is for the F1 score, F1. So if you had the F beta, jahan pe, beta is going to be maybe 2 or 3 or any number that's greater than 0, right? Then you can't use the shorthand because this is specifically for when, these two things are equally weighted. This is going to be the simple harmonic mean, us lihaaz se, right? So just just verify ke, when you calculate the F1 scores for the two models in that example, that they end up being the same thing as for when you took the long way route. Now, a final cheese hai कि this is from last year's quiz actually. कि we have a small condition over here. कि given that the model has no true negatives, for that's when A22 is equal to 0, so no true negatives, and the accuracy of the model is going to be equal to the F1 score, find a relationship between A21 and A12. So basically the false negatives and the false positives, the off diagonal terms, right? So uske andar we can just plug it in like this, right? Okay, accuracy, that's just going to be the main diagonal plus everything else. A12, A21 plus A22. And the F1 score, that's going to be the exact same thing जो हमने यहाँ पे निकाला है. 2A11, 2A11 plus A21 plus A12. Now, if A22 is equal to 0, then I can say, catch a fine, ye 0 ho gaya, ye 0 ho gaya. So then I'm going to be left with A11 plus A11 plus A12 plus A21 is going to be equals to 2A11, 2A11, A21 plus A12. Now you can see कि अच्छा numerator के अंदर ना I have A11 common, so मैं यहाँ से cancel out कर लेता हूँ. Then I'm going to cross multiply. 2A11 plus A21 plus A12. And then because there's there's a factor of 2 over here, this whole denominator is going to be upscaled by a factor of 2. So 2A11 plus 2A12 plus 2A21. Now this and this are going to be cancelled. Then I'm going to have 0 is equals to A12 plus A21. That is finally going to give me my answer, K. A12 is going to be equals to negative of A21. So that basically means that it should technically cancel out, but that's not really possible because A12 and A21, they have to be non-zero. They have to be non-negative numbers. So इसका ये मतलब होता है कि A12 is equals to A21 is equals to 0. Right? So that was another example. Does anyone have any questions? So really sorry that this became really untidy. I'll upload a slightly cleaner version to the LMS after the tutorial is over. Okay.
I have one question. What does this essentially mean in terms of true positives, true negatives, all of these things?
So this itself, now, this was just a for demonstration purposes, right? कि मतलब this was just a question that we made off the top of our heads. कि suppose कि there was a situation जहाँ पे there were no true negatives and the accuracy was equal to the F1 score. Then this would basically mean कि every single time that the model predicted something to be a positive, na, it was right in assuming so. कि those were basically the only predictions that it made. So अगर मैं यहाँ पे बोलता हूँ कि there's no true negatives and A12 and A21 has to be 0, that basically means कि in every single case, na, according to this data set, because suppose you had this, perfect classifier, that just means that the model was always right in predicting a positive. And that also means that the data set ke andar hi na, there were no instances with a negative class. There were only positive instances, which the model kept predicting. Acha, ye positive hai, ye positive hai, ye positive hai, ye positive hai. So actually, that brings up another small topic. Okay, suppose that you had a data set, right? Suppose you had a data set that ideally what happens is कि suppose you had 50% examples with like a positive class and 50% the hell's going on with a negative class. So इसके अंदर क्या होता है कि because these two things are equally distributed, right, the accuracy actually becomes a very valid measure of the model's performance, assuming that it's been trained properly. But अब क्या होता है इसके suppose you had something along the lines of 95% positive instances and 5% negative instances. So if you guys remember the copper and the gold example, right, जहाँ पे you considered the realistic extremes. Okay, you suppose that every single coin was copper or every single coin was gold. तो उसके अंदर ये हो रहा है कि imagine if I had a dummy classifier, right? The dummy classifier is going to always predict positive. अब इसका मतलब क्या होता है कि it's going to be 95% accurate. If it just predicts positive, now that is going to be 95% accurate. But that's not really a helpful thing because suppose in the real world, na, when it gets deployed and it starts coming against examples जहाँ पे there's जिनका label negative होना चाहिए, but because it just keeps predicting positive, na, then you're going to find out कि अच्छा, the accuracy said that the model was very, very good, but that's not actually really good measure of it, is it? तो उसके तौर पे ना what's going to happen is कि you're going to see कि अच्छा fine, do I want to minimize my false positives, do I want to minimize my false negatives? उसके बाद ना then you see कि अच्छा fine, the precision and the recall ना, they're more useful in that regard than the accuracy. एक और चीज भी होती है कि as this thing approaches 100% ना, कि मतलब imagine कि uh, you had a data set जिसके अंदर there was only like one label, it was always positive, then your dummy class would have a 100% what do you call it, 100% accuracy, it would have a 100% precision, would it also have a 100% recall? Think about it. If every single example in the data set is positive and I'm always predicting positive, what does that imply? That all my predictions are correct, right? So इसका मतलब ये भी होता है कि I'm gonna have a 100% recall as well, and that basically implies that I'm gonna have a 100% F1 score too. Any questions? Okay, if not, then we can end the tutorial over here. Okay, chalo. For everyone that came, thank you. This tutorial is going to be recorded and uploaded to the drive. I'm going to upload a cleaned up version of these 10 or so pages to the LMS. Examples are going to be the same. Your quiz is going to be on Thursday. Right? Okay, so ending the meeting. So, love is everyone.